Okay, so anyway, good evening to everyone. And so I'll be talking about transceiver performance. Years ago, I just talked about receiver performance, but now we really have a situation where the transmitters may be the limit because most of the receivers are so good today, it's really hard to believe. So people have asked me, well, why did I start testing radios? And I didn't wake up some morning and say, gee, I want to test radios. It was really a fluke. And my friend in Cincinnati, CADXA, and I had Drake R4Cs, and we used them in the 160 meter CW contest, and they performed very poorly, but the reviews in the magazines were good. So the radio is what it is. So if the test says it's good and the contest says it's not, then the test is obviously flawed. So what I did was change the spacing between the two signals used to make a classic dynamic range test and squeeze them closer together so they made it through the roofing filter once we had those type of radios. Now the test before was okay in a radio designed in the 50s or maybe the early 60s. So it really had to do with changing just the test methodology that was introduced in 1975. So the difference between the tested with the 20 kilohertz dynamic range versus what I went to at 2 was like 25 dB. So a big difference. And then you got a handle on how the radio worked. So there's about 150 transceivers and a few receivers up there on my website. I certainly haven't owned all of those. In the 80s, there was a ham store in town that later became Ham Radio Outlet. And so I borrowed used equipment. There was a lot of used equipment on consignment and things like that, and I could borrow those, take them home over a weekend, and bring them back. And then in the last 10 years, I've borrowed radios from hams because $3,000 and $4,000 radios aren't in my budget to own every one of them. So thank goodness for all the hams that are really helpful. Occasionally I'll buy a radio to test it and sell it, and I did that on the ICOM 705, which came out just about a little bit over a year ago, and the FTDX 10, because there were so many people clamoring for data on it. So I just said, okay, I'll lose $100, and so those are on the website, and I'm going to talk about them. So in the last 14 years, I've been out here at my contest station where I am now, not in Denver, and get to use virtually all the modern stuff in a contest, and I'll be doing the K4 tomorrow. So here's my QTH. Kind of put a lot of emphasis on antennas, as you can see. And there's one of the three operating positions. And often in the contest, like I will tomorrow and over the weekend for ARRL 160, this will be the reference rig, and then the K4D will be the one that'll run the most. But if I hear something funny or go back and forth a bit, comparing two different rigs at the same time is sometimes kind of eye-opening. So here's some examples of where it really worked out to be able to go between one operating position and the other just by changing chairs. Like the 781, that pure analog rig that certainly I didn't buy used when it came out like 30 years ago, too expensive, but I bought it secondhand, was a good reference radio because it didn't have any digital artifacts because it didn't know what the word digital meant. But the FTDX 5000 had an accessory scope and speaker set that had just a horrendous scope that was about 3/4 of an inch high. So that was pretty obvious that the 781 scope, which was probably the first scope that we ever had in an amateur rig, was much better than that. I'll talk a little bit about running the 7300 and the TS990 at the same time in a contest. That was fun. And I ran the TS590S and the 10-Tech Eagle at the same time. I kind of planned to do a 50-50, but it was easier to use the Kenwood. I guess it was just the ergonomics was a little bit better. So I ended up running it a bit more than half. One time I ran the Flex 6300, which was their low-end rig at the time with the Maestro. And then there was just some issues with CW, even semi-break-in with clicks and ticks and funny noises, and I switched to the 7300 near the end of the contest. Surprisingly, I've run the KX3 twice in two 160 meter contests. And one time I was listening to it in comparison to a Pro 3, and the Pro 3 had such horrendous AGC attack distortion, it just drove me nuts, and I never ran the Pro 3 again in a CW contest. And the final example was an early Apache from, the Apache Anon 200D. the selectivity was just horrendous on CW. And so I called up Warren, NR0B, who writes the code, and I said, what's going on here? And he had me go into some menus and fix the defaults for this digital CW filters. So the shape factor went from over 4:1 to under 2:1, and then the radio played fine. So it was just a case where out of the box, the defaults were terrible. So in the last 5 years, I'd say I've got a new requirement that whatever I test has to be a random sample. These radios are so complex and a lot of software, and I don't want a cherry-picked radio. So Kenwood is really good. They just have me go into a ham radio outlet in Denver and pick a random box off the shelf. And I did that with the 590, the 590SG, and the 990. So, and the 890. But a lot of times I just have to borrow a rig, because if it's direct sales from the dealer, from the OEM, like Elecraft or Flex, well, then I don't know I'm getting a random sample. So I just borrow it, like I'm borrowing a K4D right now from another ham in Denver. So we don't want to just focus on the receiver performance, because the other side of the equation is the transmitter. Ten-Tech Orion started the new trend with the back to a low IF instead of the up conversion. And of course, then the Elecraft came along with the K3 and really took the world by storm with the low IF. We call it down conversion. That's not really correct if you're on 160, for instance, but it's a, like a 8 or 9 megahertz IF. So now pretty much everything is of the new stuff in the last few years is a hybrid superhet, which means it has a direct sampling scope, but it's a standard superhet like a K3, or the direct sampling radios like the ICOM, the Flex, or the Apache. But all this time, when the receivers have been getting drastically better over the last 15 years, the transmitters have actually gotten worse, and I'll give examples of that. So there's where we need to really pressure the equipment manufacturers. Let's quit spending any more time on these phenomenal receivers, which are more than good enough, and let's see if we can improve the transmitters. So the difference in receive was whether it had a wide first IF filter, and of course the up conversion radios had a first IF above 10 meters in case of some of the Yaesus, or above 6 meters for most. So there was a big difference in how it performed. But then if it had a low IF, like the K3 or the 890 or the 101 from Yaesu, well, the dynamic range was virtually the same at 2 kilohertz or at 20 kilohertz. And so the numbers were just amazing. You couldn't buy a 100 dB radio back 15 years ago. Then we have the direct sampling from Apache, the K4 is direct sampling, and the Flex and the ICOM, of course. So there's no roofing filter. So in that case, if you're testing it, it doesn't matter how you test it from a spacing standpoint. And pretty much all the direct sampling radios today are about 100 dB, which is just, a big number that we never dreamed of, like in 1980. The one case where the hybrid or just the standard superhet, like a K3S, is if we've got a signal that's like 80 over 9, probably line of sight. From a blocking standpoint, the K3S has about a 30 dB advantage over the direct sampling radios, but that's a number that you probably can't really see in real world, because that's measured with an extremely clean test signal, like a crystal oscillator. So maybe the difference is more like 20 dB or even 15 dB, but it still has an advantage. Excuse me. So we were talking before the 7 o'clock hour about noise blanking and urban noise, and this is really a problem. I moved to Denver right out of college in 1969, and say for 50 years, I would say that the local noise from your house, your neighbors, your power companies or whatever, probably went up about 3 dB per decade, maybe worse. So line noise is a problem. I don't think the power companies keep their plant as good a shape. All the chargers, like for an iPhone or any kind of smartphone, they're switchers. Of course, computers are all switching power supplies. household appliances, your dishwasher, your washing machine that's got microprocessors in it if it's a modern product. LEDs sometimes make noise, DSL circuits make noise, and of course in Colorado we're just blessed with having people that grow pot in our basement, and that makes noise. It's like can wipe out a reception for a 10-block radius. So you say, well, I've got this wonderful receiver, why isn't that adequate? But you know, if the signal's wide, I know we've all heard sideband splatter, and if we work CW, we've probably heard key clicks that shouldn't be there. And if you do have a station that's probably line of sight, the transmit composite noise, composite meaning phase noise plus amplitude noise, can really be a problem. Now, in the ARRL 10-meter contest just a year ago, the next ARRL contest will be next weekend, there was one station with the CW key clicks were 35 kilohertz wide. Of course, I didn't have a hard time finding him, and I wrote down his call. And then there was another station that was unbelievable. Its broadband composite noise was 50 kilohertz wide, and that did take a bit of sleuthing to find it because the noise was that broad. But I did find him and write his call down too. So both of those were just horrendous examples of terrible transmitters. There must have been something broken. So today we want to look at the dynamic range, particularly for CW and RTTY. I'll talk about why for sideband it's not as critical to have a 100 dB radio, for instance. We need the noise floor to calculate dynamic range, but every radio today is be hard to say it can't receive a weak signal. I mean, sensitivity is fine. And then we've got these other things, the synthesizer, I'll talk about that. Big improvement recently in the last just few years. And then the broadband, whether it's transmit noise, sideband splatter, or key clicks. So the league invented the term reciprocal mixing dynamic range in 2012. And then they kind of forgot about it for a year or two, but that is a rating for how clean the synthesizer is in your radio. And so that limits you on receive and also on transmit. So if it's got a lousy synthesizer, it affects both. So of the superhets that are really clean today, the K3S was a big improvement. You could upgrade your K3 with the new synth. I don't think you can buy it right now. Hopefully they'll run another batch sometime, but you know, K3 is kind of orphaned now. The very expensive ICOM 7851, and then all the new Yaesus, the 101D or MP or the 10 have amazingly good synthesizers. Close in, the TS890S or the ICOM 7610, not quite as good. I'll give some examples of that later. But if you get out to 100 kilohertz, like you've got a neighbor that's on sideband and you're on CW, at 100 kilohertz spacing, those two rigs are really excellent also. The direct sampling rigs, you'd have to really goof up to make the phase noise bad on a direct sampling rig, because you just have to put a decent clock oscillator in it. So you didn't have to design a fancy synthesizer, but thank goodness the ham OEMs know how to build good synthesizers. And I want to commend Yaesu. They used to have terrible key clicks and terrible transmit composite noise. And with the latest 3 rigs, with their latest updates to the firmware, they've really have good products in that respect now. So if you're not really thinking much about phase noise, and why would you be, here's a graph to explain why it's an issue. You don't listen to your local oscillator or your clock. So let's look at the left there where we've got this little bullet nose, and that's a weak signal. And he's, you know, DXCC 100, or he's some multiplier, and I want to work him. But what if there's a really strong signal nearby, really strong? And nearby is relative, and I'll explain that. But what happens is every local oscillator, good or bad, has noise sidebands. And you hope they're kind of Gaussian, they fall off. They may or may not, but the noise in the local oscillator mixes with the strong signal and puts the local oscillator noise on top of the strong signal. So over at the right, the strong signal that was just straight up and down, it could have been, quote, a perfect signal. That doesn't exist, but, you know, a really good signal. But then if your receiver had all that a poor oscillator, that noise would end up on the strong signal and cover up the weak signal. So that's what the synthesizer noise or the clock noise is all about. I'm going to have a couple screenshots of contests with a couple different rigs. Now this was the ARRL 10-meter contest 2 years ago at the bottom of the sunspot cycle. That contest is next weekend, and I happen to be running a TS890S. So there were over 20 stations here at the bottom of the sunspot cycle in a 10 kilohertz bandwidth. They were pretty weak in some cases. So how did I have my radio set up? I'm out in the country. It's a quiet location. So I was on 10 meters. I had the preamp on. Well, how do you know whether to turn the preamp on? I'd suggest that all of you, if you've got a dummy load, make it easy to access with some sort of an antenna switch, like an alpha delta or whatever. And if you're, let's say you're on 10 meters or 15 meters, and you go between your dummy load and your antenna with no signal tuned in, band noise should go up noticeably. If it doesn't, turn on your preamp, or maybe turn on preamp 2, because you want about an 8 or 10 dB difference in band noise increase over the noise of the receiver. If the noise only went up 3 dB, and you can measure that, but by ear, 3 dB is not much. That means your receiver's creating half the noise, and the band noise is the other half. Well, you don't want your receiver to be the limit by creating half the noise. So that tells you when to turn your preamp on. On the lower right-hand part of the screen there, you've got the audio peak filter. I don't make them super sharp, but it takes some of the noise out of the picture. So I'll typically set mine for like 300 hertz or 250 or something. And I like one that's not as narrow as like what's in the K3 or the K4. That's just personal preference. Now here's the contest 2 years ago that's happening this weekend, the 160 meter CW contest, and I consider this a real good test for a radio for dealing with lots of signals that are strong. You might even have locals that are, who knows, 80/9. So in this case, as you can see in the upper middle, I've got the audio peak filter on, which I always do on CW. There's over 30 stations here in a 10 kilohertz span, and this happened to be an ICOM 7610. And over in the left, well, of course, the preamp's off. Why is that? Well, on 160 meters at night versus 10 meters at the daytime, band noise is 30 dB louder, typically, on 160 than on 10. Well, every radio today is sensitive enough on 10, let alone 6, because every radio today that's new covers 6 meters. So we've got too much sensitivity, too low a noise floor. So what you don't want is AGC running on band noise, because that's really tiring. So if you're an S&P operator, search and pounce, or even if you're running, in between working a station, you don't really want band noise to be absolutely as loud as a station that's 30/9. So most radios, the simplest way to adjust the AGC threshold to be above band noise, let's say 6 dB or something, is to put in some attenuation. Because we've got that 30 dB margin, so you can put in 20 dB attenuation and you're not going to reduce sensitivity at all on 160 and not that different on 80. So here's my example. When I said I ran 2 rigs at the same time a few years ago, I didn't have anything new to test like the K4 this weekend. So I had the 7300 and the 990. Well, those are vastly different radios from size and price and features, but they're both really good radios. Well, the 7300 on 160 or any band only has a 20 dB attenuator. It's either nothing or 20. Well, if I was going to compare the Kenwood to the ICOM, I had to make it fair. So I put the Kenwood with 18 dB of attenuation and the ICOM with 20, because that was my only choice. I'd never done that before. I'd only run 12, like in this picture of a 12 dB of attenuation to get the AGC threshold where I wanted it. Actually, I loved it. It was tremendous. Now, I did have to turn up the volume control, maybe 5% of the time. But most of the signals, look at them, they're showing up on the scope. They're not at band noise level. And the band noise was so modest that it didn't tire me at all. And that was just great. Now the flex and the Apache adjusted differently. You adjust on the flex a slider that's called AGC T for AGC threshold, and you just adjust that until the band noise starts to drop. And with the Apache, you've got a horizontal line that goes across the screen, and you move it up until the band noise drops however much you want it to drop. So there's different ways, but they all do the same thing to get AGC threshold above band noise to reduce fatigue. There's a new feature that's going to be coming out for the Apache. It's currently in beta. It's not available yet to download, but it automatically will adjust that AGC threshold real time. So that'd be really nice because your band noise varies during the time of day or direction. Like if you've got a Yagi, in my case, let's say I'm on 15 meters. My noisiest location is usually towards the Caribbean or South America. The quietest is usually towards JA. And in a contest, I'll be switching between two Yagis on 15 or 10 or 20. And so that adjustment of the threshold would not be constant. So we've looked at, oh, I forgot something here, sorry. Now, the thing that I didn't know when I took this picture, which was really just to show band density on 160, was on the left there, a signal that looks kind of wide, where it says key clicks 5x. And you can see that on the band scope, and you can see that on the waterfall for sure. And that guy is just really wide compared to the signal over on the right, where it says clean. Now he's 3 dB weaker, but 3 dB weaker is totally insignificant. But look at the waterfall. On the clean signal, it's like, on my screen, 1/4 inch wide, where over on the left, where it says key clicks 5x, it's like 1 inch wide. So that's just terrible. So that key click is a problem, and there's really no excuse for it, and I'll talk about that in more detail later. So we've got wide signals on CW with key clicks, and we have, unfortunately, typical wider signals on sideband than we would like. So Apache right now is the only one that has something called pure signal, but it's pre-distortion. It's kind of like negative distortion or negative feedback in a way. And what it does is either measures the distortion in your rig, or if you have a sampler in your amplifier, and a lot of the new amplifiers have that built in, and then this sample is fed back into the radio, and it corrects for splatter. So the station on the right that says pure signal, he's an enhanced sideband guy, so he likes a wide signal over 4.5 kilohertz wide. I wouldn't run over 2.5, but you can see the signal's straight up and down. And then the guy on the left, you can see his splatter sidebands. Now, you aren't going to see that, you know, if you're the signal to noise ratio is like 10 dB, but this was a significant enough signal for both of them that you could see the splatter sidebands with these direct sampling scopes. I mean, what you're seeing with a direct sampling scope is reality, and you can't blame it on the other guy saying, well, it wasn't me, it wasn't me. So just a real quick, be sure my Zoom's still working. I can hear occasional cough, so I assume it is. Were there any questions in the chat that we needed to answer at this point? And if not, I'll move on. So moderator, is there anything I need to cover right now? Guess not.
I don't see anything there.
Okay, fine. All right, so now we're going to look at transmitters and the area that the equipment manufacturers need to improve on sideband, CW in particular. This is the cleanest transmitter I've ever owned, a Collins 32S3, obviously out of production. You got to tune it, but it had 6146 finals and negative feedback. Not many of the tube rigs had that. So when we measure a transmitter for odd order distortions, sideband splatter, we just feed in two signals of equal strength, two audio tones, and look at the odd order distortion products. And this is real easy to do on a spectrum scope. So you put one cursor on the spectrum analyzer on one of the two equal tones, and then you put the other cursor on one of the odd order distortion products. And in this case, I put it on the third order. You can see that sort of bright dot to the left. And it, right there in digits, it says minus 36.5 dB, and that's really good. And of course, you can put it on the others. You can see how the signal, the fifth order, the seventh, and the ninth, they fall off fairly rapidly. This is a span of plus or minus 10 plus or minus 20 kilohertz. And you can see the distortion products are like 80 dB down, plus or minus 10. So this is good. Unfortunately, when you read a review or you see a spec on a radio, they don't list this what we call DBC, the distortion below the carrier, or the carrier in this case is one of the two tones. So this 36.5, that's the right way to measure it, but that isn't the way it shows up in print. So they add 6 dB to the number to make it the PEP method. Well, it didn't make the splatter any better. It's kind of like switching your car from miles per hour to kilometers. A lot of cars you can do that today. Well, if you go from 60 miles per hour to 90 kilometers, guess what? You're still going the same speed. Well, it's the same thing here, but that's what we're stuck with. So this is really a minus 42.5, which is really tremendous. And this many years old, decades old Collins. This is the second cleanest transmitter I've ever owned. This was the 50 volt PA in the Kenwood 990S, and it was only 2.5 dB worse on third order, but you can see that the odd order distortion products don't fall off as quickly compared to this. I mean, plus or minus 10, it's pretty much gone. Here it's about plus or minus 18, it's pretty much gone. So that's with the 50 volt PA, which is not common. There's a few rigs, but not most. And here's the K3, and it's certainly 10 dB worse than the Collins, and you can see at plus or minus 20, it's not down towards the baseline. The reason I'm really showing this one is to demonstrate why on sideband we got away with owning radios that had about a 70 dB dynamic range. In this case, with the Pro 3 was 75. That was kind of as high as they typically went for these up conversion radios, and maybe it was 65, 70, 72, whatever. Well, in this case, 4 kilohertz away from the two test tones, the distortion products are down 45 dB. You would hope you could work a weak station 3 or 4 or 5 kilohertz away from a strong one. But in this case, if the distortion products, let's say these are tones, so let's say he's just calling CQ contest. It's the S sibilant sounds that are going to splatter the most. So let's say the distortion products on average were only down 60. They were down 60 as opposed to 45, but if the Pro 3 had a 75 dB dynamic range, the radio wasn't the limit. So that's why on sideband we could live with the up conversion radios, but in CW was a problem. Now here what was possible with Class A, Yaesu had 3 rigs with Class A. The 101 MP now does not. It's a 200 watt rig. And the FT1000 Mark V in Class A, look at that. I mean, the distortion is tremendous on third order, and you can hardly even see the fifth order. And you say, okay, well, I'm not going to run 75 watts in Class A in a contest unless you're running 100 watt class. But here was Pete's W6XX, unfortunately SK, but here's his 8877 amp. Well, this is plus or minus 16 on the spectrum analyzer. And so he's better than the Collins on third order and virtually the same or slightly better down 80 dB. So it was possible with a Mark V and a good amplifier to be amazingly clean, but of course it's not made anymore. But we do have the pure signal, and Flex says they'll have pure signal. They've talked about it for 10 years. I sure hope to see it. Elecraft says the K4 will have pre-distortion. They won't use the term pure signal, but hopefully they do. Now here's where the case for my signal with a normal rig, a Kenwood, or maybe it could have been my ICOM. The waterfall shows that it's the one that's 2/3 of the vertical height. That's an Apache 200D running pure signal and a solid state amp with a sampler on the solid state amp. And look how straight up and down he is, just with a tiny bit of splatter. But there I'm talking on my TS890, Now we're strong, and I'm a little bit stronger than the Apache, but you can see the difference. So if we could get Flex, and of course we have Apache and Elecraft to offer this pre-distortion, we could more look like the one there that's very narrow. Back to the key clicks. This is how much difference you can make on selecting the right rise time in your menu on the modern rigs that have menus. Can you adjust the rise time on CW? Now the OEMs, up until just recently, all of them gave you such choices that were terrible. So these two graphs are of a TS890S adjusted for 1 millisecond or 6, and that was the range. You couldn't go faster than 1, thank goodness, and you couldn't go slower than 6, unfortunately. So at 1 kilohertz offset, the difference between simply adjusting your menu properly was 25 dB difference in key clicks. Now Yaesu is finally, not only did they get rid of their key clicks, they got rid of the choices of 1, 2, or 3 milliseconds. You can only pick 4, 6, or 8 with the recent firmware updates to the 3 current Yaesu rigs. And if we could get ICOM and Kenwood, and then the direct sampling like the Flex and the Apache, to not even let you pick the wrong rise time, that would be great. Oh, you say, what the heck is rise time? So here is just in the time domain, a normal scope. If you happen to own a scope and you can just maybe go you're like, oh, there's a signal. Your key clicks are affected by how quickly it goes from no power output to 100 watts output, or full scale, whatever your power is. You can see on the left, that's a 3 millisecond rise time, and it goes up pretty quickly. I wouldn't want to pick 3. And the one on the right's 10. Well, I might pick 8. But you can see that 10 goes much slower and the key clicks are much less. Back to this composite noise and real world example. That's in a case where pretty much line of sight situation, where your signals are really strong, unless it's defective, like that one on 10 meters, it was just horrendous, and it was a skip signal. So the K3S is really great with, don't worry about what minus 141 dBc means per hertz. Just look at it as a number, and we like big numbers, big negative numbers in this case. Minus 141 at 10, and it's tremendous at 100. Didn't get better because it was so good to start. But then the ICOM 7610, well, it's not as good at 10, minus 128, but at 100, it's virtually identical to the K3S at minus 142. But then we've got the Yaesu FTDX 3000 at minus 120 at 10, and then minus 121 at 100, and so it's probably just as bad at 200. So we really would rather have a rig that it improved with spacing. So to give a real world example, in Boulder, Colorado, there's a station up in the foothills, 1,000 feet above Boulder, and he's like 5 miles away, but line of sight to a station there in town. When he used to run his FT1000MP, he didn't bother the station in town on 15 meters that has a stack, and he's really a DXer. But when he switched to the FTDX 3000, it virtually wiped out the band with broadband noise like S9. So N0QO went up to the station up there in the foothills and made the measurements. So these are really real world numbers. Just a real techie nerds graph here. We need the ARRL to somehow solve their inability currently to measure more than just phase noise. You have to be able to measure composite noise or AM noise and add it to your phase noise. So the green graph that's falling off is the 7300 at 30 watts, which is probably what some amplifiers only need 30 watts. And the leak sometimes tests at 100 and at 30, and so do I. So you can see the blue graph falls off really nicely. And it's like, wow, what's the problem? So the report in the magazines are going to say it's fine. But in this case, the Roden Schwartz analyzer that's only cost $150,000. Well, you can see the black graph or the green graph are like way worse. And at 20 kilohertz offset, the AM noise is 18 dB worse than the phase noise. But you don't need a $150,000 piece of equipment to make this measurement. I make it measurement with a Perseus receiver. or if you had a flex like a 6700 or a 6600, or you had an Apache 7000, you could make this measurement by hand and graph it yourself. So I'm pushing the league to get this solved. Now, Ulrich Rhoda donated the equipment the league has now, but it only measures phase noise. So the next slide is really for future use if your club does field day. And so your club has a PDF of this. So this has data, Techie Nerd data, but you want to pick rigs for field day if you have more than one station on the same band, like CW and sideband, or today CW FT8 and sideband. So you want to pick rigs that have big numbers as opposed to worse numbers. If you read my article in November QST in 2019, it was titled by the league, "It's Time to Clean Up Our Transmitters." And I want to really a tip of the hat to the league for publishing my article, because I was poking my finger in the eye of the OEMs who now need to spend time on making their transmitters better. And surprisingly, in the same issue, November QST 2019, the league tested the Expert 1.5 KFA LD MOS amp. They tested it the normal way, and the third order intermod was minus 30 PEP. Remember, that'd be minus 24 measured on the spectrum analyzer. And they then turned on pure signal by driving the amp with the Apache, probably the 7000. And the pure signal improved it, the third order, 17 dB, and that's massive. Back in 1997, the league put out a list of the distortion products of tube type amplifiers. That's all we had in 1997. And every one of them, the third order, was down 40 to 50 dB with the PEP method. Well, QST reviewed the Alacraft KPA 1500. It was minus 30. Well, that's a whole lot worse than minus 40 or minus 50. The Power Genius, we tested that in Colorado, and N0QO's QTH. It was minus 30 on 20 meters. It was a little bit better on 40 and a little bit worse on 10 and 6. This QST review here in that same issue, this Expert was minus 30. And that's pretty much what all the LD MOS amps are. But then if I was running the TS990S, that's third order is like minus 40, and you go through an LD MOS amp, it's minus 30, so you just got worse. I happen to run tube amps for that reason, because I don't really want to make my signal worse. In addition, the acoustic noise from the fans in the solid state amps tends to be pretty high in comparison to the tube amps. Here's some couple of graphs that occasionally pop up in QST. I hope they keep doing that. On the left is the Alacraft 1500. And in this case, the blue graph is 20 meters, and it's pretty straight up to a kilowatt, and it starts to curve down a bit. So if I had a KPA 1500, I'd probably run it at a kilowatt PEP and not 1500. But then the ACOM 1200S, now the red graph is 20 meters. Well, it's straight up to 700 watts, but then it goes almost horizontal. Well, not quite horizontal, but terrible. And they did have tabular data which confirmed that. So this ACOM solid state 1200S never ran it over 600 watts. So the bottom line today, receiver performance from all the 6 major OEMs is quite outstanding. The pile-up limit might be the other guy's signal that's nearby. Sideband splatter, key clicks, or broadband noise if it's probably line of sight. So the challenge today is we force the OEMs in a way, because the radios that were much better started being sold in great quantities, and the ones that are much worse faded away. So we kind of have to do that now to say, I'm going to pick a rig that has better transmit signals. And on CW, it may just be a menu selection. But receivers improved from like 15 years ago from the mid 70s for dynamic range clear up to 100. And in the last few years, like 4 maybe, 3, the synthesizers have massively improved. So here's some data off my website to show you what the choices are like today. Now, this is the top 21 individual models. Now that's not number 1 down through 21 because there's duplicates on there. The K3 came out, and then the K3S. There's information on a K3S on 10 meters versus a Flex on 10 meters. The direct sampling radios are not as consistent as the super hits because each individual analog to digital converter chip is slightly different. So there's like 2 copies of an ICOM this or 2 copies of a Flex this or whatever. So this is the top 21 individual models. Well, right there in the middle, 99 or 100, you couldn't buy that 20 years ago. And clear down at the bottom there, the ICOM 705, the size of a brick, which I'll talk about, it's 88, amazing. And then of course we go clear up to 110. Don't feel you need 110. You don't even need 100 probably, but if you've got a radio that's 90 dB or up, you've got other things that you need to worry about. So for instance, the price difference here, $1,000 for a 7300 or 12,000 and up for a couple of these. The used market got crashed by the 7300 from ICOM because you could buy a new one for 1,500 and now 1,000. So you can buy a used 590S for like $700. N2IC, who's a big contester, he's got a pair of 590s. So you don't have to spend a fortune today to be competitive from the rig standpoint. So I finally got some data earlier this year on the K4. As you'd expect, it's a direct sampling radio. The K4 is kind of like half of a 7610. It's only a single receiver. Its dynamic range was right at near 100. If you wanted to listen to 2 bands at once, you could. You could be on 20 and monitoring 6 meters, but the input filtering the LC front end would go broadband, but at least you could do it. But with the K4D, which most people are probably buying the K4D, it's got 2 independent receivers, 2 sets of LC front end filters, and it's just from a basic architecture standpoint, just like a 7610. A lot more expensive though, but it's hopefully I have pre-distortion down the road. The HD model doesn't exist yet. Hopefully it will eventually. It'll kind of make it be much like a K3S. It'll have roofing filters, up to 3 roofing filters for each of the 2 receivers. And you can later upgrade, if this upgrade ever comes out, to a K4D. Ken N0QO and I spent a couple, 3 weeks testing a K4 back in 6 months ago or something. This firmware was version 19 back then. They're up to 26 right now, 27's in development. Lots of firmware things need fixed, so it's going to take a while. But rigs today pretty much are all upgradable. I mean, if you owned a Pro 3, it was what it was, or an older one, of course, 781. Guess what? The radio is what it was. But today, at least, because of firmware updates, bugs get fixed, features get added. Real quickly, a couple of rigs that came out in the last year. The ICOM 705 came out just over a year ago. It's a QRP rig, 5 watts on internal battery, 10 watts with an external battery, 160 through 70 centimeters. The FTDX10, a cheaper version of the 101D or MP, covers 160 through 6 and pretty good price. Unfortunately, until this weekend, I won't have any contest data on the K4D, but coming soon. In very difficult environments, like that guy that's line of sight that's 80/9, a K3S is going to probably perform better than the K4 because it has a roofing filter. You really want to mouse with the FTDX10, and you want to mouse with the K4. Comments on the 705. Now, on Black Friday, just after Thanksgiving, on Black Monday, the following Monday, you could buy the 705 for $1,300 at HRO. It has pretty much the same lab numbers as a 7300 with what's called IP plus or linearization or dither turned off. In the lab, the linearization feature of all the direct sampling rigs makes the difference that's significant. But on the lower HF bands, those distortion products are usually covered up by band noise. So far, I've never heard anyone tell me, or my own testing, that I could hear the difference between turning the IP plus, the dither feature, the linearization feature on or off. But here's my guess. A few years from now, when 10 meters is hot again, like it was, at the peak of the sunspot cycle, there'll be 1,000 signals on 10 meters, and they are going to be really strong. And I will guess that this linearization feature, whatever they call it in a given rig, will be obvious on the air, but we'll see. So the 705 ergonomics are really good. If you could run a 7300 or any of the current ICOMs, you could run a 705. Talking about firmware updates, about 2 or 3 months ago, ICOM gave a new scrolling feature for the band scope and the waterfall. This made a tremendous difference in the usefulness of the band scope. It was definitely inferior to the Kenwood TS890S, which was my favorite rig from the standpoint of CW contesting and the way the waterfall worked. But now, with the upgrade in the firmware, ICOM hadn't reached as good as the Kenwood, but it's close, and it's certainly very useful. So thank goodness again for firmware updates. I used the 705 in not QRP. I drove an amp in sweepstakes a year ago. The sweepstakes was just recently, so this year. So this was a year ago. I made 100 contacts and quit. I ran the contest that's this weekend a year ago on 160, and I had almost 400 contacts. Search and pounce. My CW is not like it was when I was 18. I worked a couple of JAs with this little 705. I worked 80 sections, which would be ARRL sections and Canadian sections, and I was on the air for over 16 hours. Then I ran the 10-meter contest, which will be this weekend from this weekend. And, working weak signals, no problem. The only trouble right now is nobody's selling an external microphone. Comes with a push-to-talk mic, but run a contest with a push-to-talk mic, forget it. So a few people on eBay are selling an adapter to let you use your normal headset or a stand mic, a desk mic with Fox. Heil or somebody's going to figure this out, but right now that was the issue. The FTDX 10, again, Black Friday down to $1,400. I think it went back up to $1,600 or whatever. Lab numbers pretty much like the 101D and the MP. To me, the ergonomics are a bit clumsy. For a lefty, the audio gain pod is to the left of the PTO and really close to it, the tuning knob. And being right-handed, I keep bumping the tuning knob. And I'm not a real fan of the menus. But anyway, the radio works really well. I've run it in the contest. So the firmware updates are up to the May ones. Key clicks are no longer a problem. It's very narrow. They keep hyping their 3D waterfall. But to me, a waterfall is only useful if it gives you a history of like 30 seconds or up to a minute. What's been going on, plus or minus however many kilohertz you set the span. But with the 3D waterfall, as soon as you send one dit or you push the talk and say hi, the waterfall goes away and starts over. Well, that's just useless. But the 2D waterfall initially was just as bad, but it's been fixed with the update. So now the 2D waterfall works just like it does in everybody else's waterfall. And was the same problem with the 101D and the 101MP. I operated it in this year's January CQ Worldwide 160 contest. I could only work one day, only worked 200 plus Qs. I was search and pounce. I worked 3 JAs on 160 and I had 45 sections. I was on the air a little over 7 hours. Selectivity was fine. The audio peak filter worked fine. I didn't like the default. It's buried in the menu, but you can adjust it. Again, the ergonomics, the only issues as far as I'm concerned. The scope needs work, and the buttons are really close together. But once you got it set up, use a mouse. It helps. Important factors to consider. Don't buy a radio with just one number, like even off my website where they're sorted by the right-hand column, like your 90 dB radio, your 102 dB radio or whatever. You don't buy a sports car that can go 150 miles an hour, but if you go around a curve, it goes in the ditch. So you look at the big picture. Operator fatigue can be an issue. Like I mentioned, the Pro 3, the AGC attack distortion on CW drove me nuts. The ergonomics drive me nuts on the FTDX10. Does the speech processor work? Some are better than others. We were talking about noise blanking and noise reduction before 7 o'clock. In an urban environment, noise is a big deal. You might pick a rig because it has the best noise mitigation because that's your biggest problem. As the firmware updated regularly, like the ICOM just was, sometimes the updates are few and far between. What's the warranty service like? I mean, everything's surface mount. You can hardly see the components. So we need good service in a timely manner. And then what happens when the rig's out of production? Can it get parts? It may be interesting to see how the K3 can be supported because Aircraft is not going to be building more spare boards anymore. So, and then the bottom line that I've said at several contest universities, at the end of the day, operating, rag chewing, contesting, DXing, whatever you did you enjoy using your radio? If it was fun, great. If you say, man, this radio is a pain in the neck, get something else. So there you have it. I'll look forward to any questions you have. Full disclosure, I've been a ham for 60 years. What have I owned over all these years? National, Johnston, Drake, Collins, Kenwood, ICOM. So right now, I just happen to have ICOM, but I've had the 990 and the 890. They're great rigs. So I'm going to quit sharing here. Go back to you guys. And if there's any Q&A, have at it.